Hello and welcome to Do-It-Yourself Musician. Today on the bench we have a really nice leveling amplifier, RNLA 7239 from FMR Audio. As you can see, of course, made in USA. FMR Audio, Austin, Texas. These are pretty cool little units. I've been looking at getting one of these for quite a while, and also the really nice compressor too. Take a look at the back here. Looks like stereo in and out and a side chain, and of course your power connector. This particular unit was listed on eBay as needs repair, so I bought it at a very reasonable price. Apparently the eBay seller says that I guess he plugged in the wrong power supply to this and blew it up. So we're going to take a look at it and see if we can repair it. Hopefully it isn't beyond repair, blown up so bad that we can't do anything. I do have a power supply that he sent with it. This seems to be a no-name jobby. I don't know if this is what FMR supply is or not. It is the right barrel connector. And this is 9-volt AC at 1 amp. And let's see. And power unit is 9-volt AC at 500 milliamps, half an amp. Since I have a little bit of information about it, the seller said that he thought he blew this up. I'm not going to plug this in first. I'm going to open it up and see if we can test a few components in the power supply to see if that is true. And in fact, is it blown up, or we can plug it in, or what? I think first of all, what I want to do is plug this adapter in and just make sure that it is putting out the correct voltage. Okay, let's have a look at this adapter, and right off the bat, you're going to notice a problem here. That little symbol right there, that's DC. That's not AC. I did try to look this thing up online, this T-Power adapter. And it's interesting because it's marked AC, 9 volts. Yet it is clearly marked with a DC logo. So I'm going to guess that this isn't even an AC power adapter, though when I looked online, this part number is listed as an AC power adapter from a few places that I could find it. And I kind of wonder if this thing is sold under the same part number, but being both types of adapters or some weird thing like that. So right off the bat, this is suspect right here. So let's go ahead and plug this thing in and test it and see what it gives us. So we're set up DC on the meter there. Let's just go ahead and see if we can read anything off this bad boy. Nothing. Not getting anything. Let's try it on AC. Okay. So around about 6 volts. These things really don't fit real good in there. Yeah, that's very strange. I don't know. I mean, the thing is clearly marked as that symbol, that's obviously a DC symbol. So this is clearly marked as a DC power adapter, and it doesn't put out any DC. It's only giving me an AC volt signal, which is not enough. It needs 9-volt AC, not 6. So right away, this is really suspect right here. So I think what I want to do is check the power supply inside of the unit, and we'll see if anything is broken in there, or anything exploded, or anything shorted, and just go from there. Okay, on this case, it looks like we've got some screws on the side. There's end plate screws on front and back. I did notice over here seems to be some kind of shmoo in these screws. I don't know if that's supposed to be there, or maybe that's how they know if you got into it or not. But I don't care. This is not a warranty repair. So I'm going to go ahead and try to pop these side screws out and see if we can get this case open. Okay, I've got all the 8 screws out of the side, and as I was unscrewing this, I noticed something. Well, of course, there it is. Hear that? That's probably not good. I'm kind of thinking we're going to find something with its ass blown out. Some components laying in the bottom of this, possibly. Okay, well, it's not in the bottom plate. Oh, no. Those are just kept screws. Or, excuse me, nuts. That's how. This is one of those, I don't know, extruded aluminum cases, I guess. And that's just how they keep. I thought something was going to be blown up and just floating around in there. Okay. Pull the top off. Got shmoo everywhere. Okay. So at first glance, I don't see anything too badly blown up. This cap looks to be pretty bulged to me, though. I think what I'm going to do is I'm going to go ahead and, just because of what was said that this is possibly blown up, I'm going to go ahead and just test components all around the power supply input. Since this is an AC input, they're definitely going to be rectifying the AC into DC rails. And I'll try to figure out what power rails they have in here, and I'll check all those, or check how those are laid out before we actually apply power to it, and then we can check the voltages on those rails. So let me take a look at that and see what I can find. Okay, I've had a poke around in here in the unit's power supply here, and I can't find anything wrong. I've checked all these caps. I've checked all these diodes, this fuse here, this diode. There's some voltage regulators along here, and I've checked all that stuff, and honestly, I can't find anything shorted or anything wrong or anything blown up for that matter. So, you know, my thoughts are is that it was just being plugged into the wrong power supply. So what I do have is a proper power supply. This one will put out 9 volt AC. It's for an Alesis, but it'll certainly work with this. It has the same barrel connector and everything, so it should run this 9 volt AC 500 milliamps fine. So I'm just going to go ahead and power it up on this and check some voltages in it and see what we get then. Okay, I've got the other power supply plugged in. I'm going to plug this in, and hopefully nothing goes bad. Heard a relay go. Didn't sound nice. And I got a light on the front. Okay. I don't know. Nothing seems odd yet. Let's unplug it and listen. Yeah, it's this little TQ relay here. It's a TQ2 5 volts. Panasonic. Let's plug it back in. Yeah, the relay went. Lights are on. The bypass for the relay. That seems to function. So what I'm going to do is I'm going to go ahead and check voltages in here and see what we got. Okay, we're set up on DC volts, and let's just turn this on and poke around and see what we can find as far as the voltages go. Let's power it back up. Okay. See if it's going to be hard to get everything in here. I don't want to blow this up, so just bear with me. All right, the first thing here I believe is going to be minus 15 volts. Yeah, there's minus 15. That is a LM79L15. Here's an LM78 L15. That's positive 15 volts. And then here, this should be 5 volts off this regulator. Let's see what else is in here. Those other ones just look like op amps. Okay, so it seems like we have most of our power rails, and I've got a relay that's functioning, that even functions via the front panel control. I got front panel lights. The thing seems to be operating. So I think the next step is to put a signal into this thing and see if it functions. Maybe it was just that they were providing 6 volts to this and not 9, and it wouldn't work. Let's go ahead and hook it up and we'll check it out. Okay, so you can see here that I've got my function generator, and it's generating a 2 kilohertz tone sine wave, and it's about half a volt, 500 millivolts. Sorry for the camera fumbling here, but if I can show you. So I've got that going into the unit, and then coming out, we're going over to the scope, and I'll show you that. Okay, so I actually moved the scope up above the counter here so we can see exactly what's going on in one shot. Right now you're looking at the bypass signal of the unit because it's not plugged in. So I'm going to plug it in right now. And there you can see it changed it a bit. Now if I go and hit the bypass on the front of the unit, so you can see that the unit is doing something. And by the way, the controls are set to threshold 0, ratio is 1, the attack is 7, release is 7, I'm moving those back to 1, and the gain is 0. So there is a bit of attenuation through the unit, nothing to be worried about. Here's the gain control. As you can see, it works. It's very smooth. We'll go full on that. That's full up gain. Looks good to me. There is what would essentially be, and don't worry about it, they just captured it in a different way. That's 50 millivolts of division instead of 100 like it was. Let's see. Yeah, there's the 100 millivolt signal. Anyways, yeah, that would be what would be unity gain. So if I want to bring my ratio up to 6, and then I'm going to bring my threshold down. And yeah, see it's starting to act on that signal, which means it is, you know, you see right there that is compressing that signal. And that's minus 40. So if I go down and compress this minus 20, then give it some makeup gain to kind of get back to where we were. And here is moving the ratio knob down. There's 1. That's 25. I guess that's limiting. And by the way, as I'm doing this, the gain reduction lights on the front panel are functioning. Alright, let's take it back to 0 gain. Now if I kind of let me compress this signal a bit here. The threshold to push down on it, and just let me turn up the output on the function gen. And let me get you a shot of the unit here. Okay, so here's what happens to it when I turn up the voltage on the function gen. Which that's equivalent to a signal, you know, music pumping through there. So, you know, I'm going to just say that this thing works. Of course, we're not listening to it right now, so I'm going to do a further test where we actually use this on something. We'll try to compress drums or something with it. And just check out the audio quality. But before I do that, let's unplug the 9-volt AC supply that I have in it right now. Let's plug in that 6-volt supply, or that non-functioning, sorry about the noise, non-functioning 9-volt supply that's given us 6, and let's see if the unit works. Okay, I've got this other supply. I'm going to plug that in. It should return to what it was doing if it works. But look at that. We have nothing but lights across it now. So that is a dead giveaway that this supply is bad. It doesn't work. There's our good 9-volt AC, and you can see that we're back to the lights now. And I can adjust it at will. Okay, so there you go. Like I said, we'll do a music test on this. I guarantee you that's going to work like a charm. But like I said, let's do an audio test to hear it for ourselves. And that's coming up right now. Okay guys, so I really don't have a good test setup for this. Some of you may have noticed that my workbench setup has changed since the last video, and honestly the CV19 has hit me pretty hard. I work in the live events industry, and our business has been closed since, I think March 19th. But yeah, all of my Tac Scorpion console and all of my effects and tape machine and everything is all in storage right now. So this is about the best little setup I have. I've got a signal, a kick and a snare coming from MPC 2000 drum machine. I'm sorry, they're just samples. It's going into this Behringer here. That's coming out of the Behringer on the aux end to the RNLA. From this back into the Behringer, then back into Reaper back there, which you can see that signal. So we're going to record into that. And just play with the knobs here to make sure this works. Okay, so we're getting a signal now. Let's go to about 2 on the ratio and start to bring this down. Threshold. So you can already hear it. You can already hear it grabbing there. Nice release. There's the bypass. Let's bring the ratio up. this thing sounds really good. Bring this on up. You hear it grabbing a little more. Let's bring the threshold down. Yeah, it's really crushing it there. Yeah. So you could really crush some. You could really crush some overheads or something, room mics with this thing. Sounds really good. All right, well, I'm going to say it works. It sounds fantastic. So in case you guys are actually wondering how this power supply works, because it takes in a 9-volt AC signal. This arrangement of caps and diodes here is a voltage multiplier. So what happens is you have 9 volts AC coming in. There's a fuse. This is a reverse polarity protection diode, probably. In case you put DC in it or something, I guess that would probably take care of it. But these 4 caps and 4 probably these first 4 diodes in here, those all work together to make a voltage multiplier. And this last diode and cap, I believe, is feeding out this way to this 5-volt rail linear regulator. You got a, what is it? It's a LM78LO5 for the 5-volt rail right there. You have LM78L15 for the positive 5 volts, and then LM79L15 for the negative rail. That's how you can take a smaller voltage, pump it up to where you can get enough voltage in here to run your op amps, plus and minus, and then plus your 5 volts for things like your micro and stuff. Let's take a look and see what the input of these chips are. Just curious how much this voltage multiplier is actually multiplying the voltage. So let me grab a meter and we'll check that out. Okay, well, I think that's everything in shot. So let me get in here and see what we got. This is the input of the 5-volt linear regulator. Seems to be about 12 or 13. The input to the positive 15-volt regulator is 26 volts. And then the input to the negative 15 volts. Let's see where that, oh, there it is. That's 26 volts there. So that generates a good healthy supply for this. There's still this bulging cap that I want to take a closer look at over here. I do see some junk on top of it that I want to scrape away to see if in fact this thing is split. I did check the voltages that are going to these caps, and they're not anything outrageous. It's about 26 volts, I think. These are rated for 35. These are Panasonic caps, but I do want to look closer at this one to make sure that it is not split. And also I may desolder this one and check it out of circuit, because I know this might have been damaged when that power supply was damaged or something. I don't know. I just want to double check it. All right, so I went ahead and remove this capacitor out of there. And let's just give it a check here. All right, so you can see that this reads good. This is a 470 at 35. Problem is that it is split on the top. It's going to be hard to see, but you can see that little. I just scraped away and with a dental pick, and a dental pick just pierced right through that with like no effort. So for whatever reason, this cap has been split. And it was also, when I pulled it out, it was very greasy feeling. Even though this reads good, I'm just going to replace it. I don't know what happened to it, but something's obviously gone wrong with it. And I think just to be symmetrical, I'm going to go ahead and replace all of those. So I'll order up some new Panasonic caps, power supply caps, and we'll put them in there. And this is what the specs on it are. They're 10 by 16 millimeter with a 5 millimeter lead spacing, and this is the Panasonic number that I'm going to order up for it. I'm also going to order up a new power supply for this thing. It's interesting to note, when I went to FMR Audio's website just to see if I could order a power supply for this, it turns out you can't, which may be what led to this problem in the first place. Is that, I don't know, I think their website said around 2014-ish or so, they had to move away from these 9-volt AC power supplies due to some government regulations. All current versions of this are going to operate on a 12-volt DC, I believe. So the internal circuitry is going to be entirely different in the newest version of this. Nearest I can tell, this version comes from 2013. I don't know if this number here has something to do with that, but some of the components are marked 2013, and then there's this board revision here that's saying 2012. And like I said, if you go on their website and look under the accessories and the power supplies, you'll see that you're not able to buy this from them. Actually, these are available from Jameco though, so I'm going to order one up from them to operate this with. I'm not going to try to repair this or anything. It's just not really worth it. Besides, most of the time these things are glued or welded together. I pulled this up and there's not a screw or anything, so I'm just not going to worry about trying to repair this. Okay, we got the new capacitors in. These are 470 at 35 volts Panasonic LM series. And you know they're going to be good because they're gold. Alright, just kidding. I'm going to desolder all these, solder all these in, and we'll power it up and test voltages. It looks like all of our negatives are going that way, so they're going to the right, so that'll be easy to remember. Okay, so there's all the new caps installed. Completely recapped, cleaned up the circuit board and everything. I do have the new power adapter that I got in from Jameco, the Relia Pro. This one's 9-volt AC output, 500 milliamps. Let's take a look at this guy. All right, let's see what we got here. All right, input 120/60, output 9-volt AC, 500 milliamps. That is perfect. And it has the 5.5 by 2.1 DC barrel plug on it. Let's go ahead and plug her in and test her out. This wire is kind of thin. I don't really like that, but you know, the installation on this is probably going to be in some rack somewhere, so it's not really going to matter. Let's bring a meter in and set up on AC. Now let's see what we get here. Yeah, 10.3 volts AC. That's perfect for an unloaded AC. So let's see. Let's try to get a shot of this. Let's go and plug it in. There we go. Perfect. Everything seems to work. All right, cool. All right, well, there you go. Okay, well, it looks like it's working. Of course, we'll test again the voltages and also give it another audio test, but I'll spare that for you guys because this video has been going long enough. That's about it for the repair. If you want to stick around, I'll kind of go over some of the components in this, but that's about it for this. Thanks for watching. Okay, so some of you guys might want to see inside this thing to kind of know the parts involved. I already showed you this power supply section. It's all high quality Panasonic capacitors, electrolytic capacitors throughout. Obviously it's surface mounts, very modern build, very high quality components in this thing. Of course, it's based around the that 2181C VCAs. Get a little closer look at those. Two of them there, 2-channel device. The 2181C has a little bit more total harmonic distortion. It's 0.005 as opposed to 0.0025 for the 2181A. This box, they do say that it is a color box, if you will. So maybe that's why they're using the C versions of that. Of course, very high quality Panasonic TLQ relay in there. These two trimmers trim the THD of the VCAs. This is a Analog Devices OP275G dual JFET op amp that's working in the VCA circuit. The rest of these op amps are all TLO72s, classic choice for audio op amps. And then over in the control circuit is a Freescale NXP microcontroller, an MC9 SO8AW16. It's an 8-bit micro, and I think it's like a 44-pin, 48-pin thing. I'm not sure. And coming off of that is this chip here, which is a TLC7524C. That's an 8-bit multiplying DAC. That's a digital to analog converter. That's probably all for front panel-y control stuff, I bet. This little chip right here is an Analog Devices ADG419BRZ. That's an analog switch of some type, and again, I'm sure that's for control from the micro. And of course, there are some things here on this front panel PCB. There's probably a driver for this LED array and some additional op-amp buffers, I'm sure. It also looks like, you know, all of these bipolar surface mount caps in the audio path are probably Panasonic's. Very modern though. It's not vintage in any way, except for these 8-pin SIP packages and the VCAs. You can get these in a surface mount SO8 package, I believe. Anyways, yeah, it's very high quality and it sounds pretty good. So now all I need to do is get 2 of the really nice compressors to go with this, because these are 1/3 rack units wide, so you can put 3 of these in a 19-inch rack space. So I think that about covers it for this thing. I didn't dig up a schematic or anything, so I didn't want to reverse engineer it or anything, but that's kind of basically what's in here. So, all right, thanks for watching.